Hi Middle 3, how are you? Today we will talk about our first lesson in algebra in Middle 3. And before we starting in Middle 3, we want to know that there are some lessons in Middle 3 are so easy. In fact, all of Middle 3, all lessons are so easy and so useful in life. So let's begin. I know every one of you had one day in cinema hall, and when you enter the cinema hall you will see this view, many chairs, okay, and now imagine that your ticket in the cinema have a seat number 134, and now you enter this hall and you begin searching chair number 134. I think when you will search 134, it's not easy to find your chair because you have no argument, you have no system to search your seat. So we invent a numbering system to make this process more easy. How we invent this system? Now, what if I replaced your ticket, which said that your seat number is 134, and I told you that your seat is in the second row, chair number 3. So you will go directly to the second row and count 1, 2, 3. So I reach my chair and it was more easy. So in the second choice, we make the searching process more easy and comfortable. Okay? Okay. Now, what we have done in this numbering system, we had numbering the rows and numbering the columns and begin to numbering each chair with 2 numbers. One of them is a number of column and the other is a number of row. So we had a chair which numbered by 2 numbers. The first one referred to the column number and the second one referred to the row number. Okay? Okay. Let's see how this example will be more useful in our lesson. Here the cinema hall, and in the horizontal line we have the chair number, and in the vertical line we have row number. If I replaced these two data with 1, 2, 3, 4, 5, 6, 7, 8, and the column numbers will be A, B, C, D till E, H. Okay? So, when I want to count or want to determine how many chairs we have in this hall, so I need to count the intersection points between every row and every column, and I will determine every point of intersection by 2 numbers, like I determine my chair. So this number A, okay, will be 2C. First, I determine the horizontal number, then the vertical number. So it will be 2C. And I put these two numbers, which is 2 and C, into brackets. So I have something called ordered pair. We have studied ordered pair in junior stage. Okay, so ordered pair is a pair of numbers. It means two numbers. The first one, which is 2 here, refers to the horizontal distance, and the vertical distance refers to the second number. And I call them first projection and second projection. Now if I want to determine this green chair and want to know its coordinate, the coordinate of this chair will be the same question. Tell me the ordered pair of this green chair. So it will be, first begin with the horizontal distance 4 and the vertical distance B. So this green chair called 4B. So now if I want to translate this example to algebra form, so I have a set of rows intersected with a set of columns, and I write it like that. This X, this red X, doesn't mean multiply, it means intersection. Okay, so when I want to find the intersection points between sets of rows and sets of columns, first I will determine the items of each set. So the set of rows will be 1, 2, 3, 4, 5, 6, 7, 8. Intersection with the set of columns, which is A, B, C, D, E, F, G, H. And I find the chair, every chair number by find the intersection point between every item in the first set and every item in the second set. So all chairs I have, all the product of chairs I will have something like that. What is this? This is a big set. Begin with the brackets of the set, braces, and including some ordered pairs. Every ordered pair, like 1A, is a chair number. 1A is an ordered pair. Its first projection, which is 1, belongs to the first set. And its second projection, which is A, belongs to the second set. So I will have the first item in the first set, and I will distribute it on every item in the second set. So I will have in the first column chairs named 1A, 1B, 1C, 1D, 1E, 1F, 1G, 1H. So I distribute 1 on every item in the second set. When I finished with 1, I will have 2 and will distribute it on every item in the second set. And I will do that till I finished every item in the first set. So I will have this product of chairs, and that's what I called Cartesian product. This product, this answer, this intersection is called Cartesian product. So now I will tell you something about Cartesian product. What is Cartesian product means? If I have two finite sets, x and y, finite means set I can count its items. It's not infinite, it's finite, like x. When I said x is a set, have 1, 2, 3, so it's finite. I can count its item. Again, if I have two finite sets, x and y, so x crossing y, I don't call it x times y. I called it x crossing y, and it's called the Cartesian product or Cartesian product. Is the set of all ordered pairs. Is the set, this Cartesian product is a set of some or ordered pairs. These ordered pairs have two projections, okay, or two numbers whose first projection of each of them belongs to x, to the first set, and the second projection of each of them belongs to y, which is the second set, as we noticed in the previous example. So x crossing y, when I have two finite set x crossing y, and I want to find x crossing y, which is the Cartesian product. So I will have a set have some ordered pairs. These ordered pairs, their projections is A and B, where A belong to x and B belong to y. This will be more easy when we see our examples. Now, if I have a set x equals to 1 and 2, this x contains two items, 1 and 2, and y contains three items, 5, 7, 8. And I want to find x crossing y. So I will have a set, and then I will have my first item in x, which is 1, and I will distribute it in on every item in y. So I will have ordered pair 1, 5, 1, 7, 1, 8. Then I will use 2. So it will be 2, 5, 2, 7, 2, 8. That's all. But be careful. When I said to you x crossing y, then I will told you y crossing x. The order is very important. Which is my first set and which is my second set? Order is very important. So when I want to find y crossing x, I will use the set y as a first set, and I will use every item in y and distribute it in every item in x. So I will begin with 5, so 5, 1, 5, 2, then I will use 7, so I will have two ordered pairs, begin with 7, 7, 1, 7, 2, then I will use 8 to have 8, 1, 8, 2. So it's crystal that x crossing y doesn't equals to y crossing x. And it's noted too that x crossing phi equals phi. x crossing phi equals phi. Why? Because phi is an empty set. So when I'm crossing x here, which is 1 and 2, with an empty set, so I will have no ordered pairs. I will have one and will distribute it on the second set, which is phi. So I will find no items to distribute on them. So I have no ordered pair. So I have no items in the product, in the Cartesian product. So the Cartesian product will be an empty set, which is phi. Now I want to find the Cartesian product x crossing y, and I have x like the previous example 1 and 2, and y 5, 7, 8. I find this Cartesian product and I want to represent x crossing y graphically. I want to represent x crossing y graphically. Okay, so I will told you about the first method to represent x crossing y graphically. It's something like the Cartesian graph paper, which we all know. Okay, I will have two lines. First one horizontal, and it will represent the first set. The first set. I said x crossing y. So the horizontal line will represent x. X and y here doesn't mean x-axis and y-axis. X and y just two names of the sets. Again, when I want to represent the Cartesian product of x crossing y, and the ordering is very important, so I will take x and represent it on the horizontal line, and will represent y in the vertical line. Okay? X and y here is not coordinates. They are just horizontal and vertical lines represent the items of each set. So when I represent y here, I didn't begin with 1, 2, 3, 4, 5, 6, 7, 8. Because this line represents only the set of y, which is 5, 7, 8 only. Okay? This is something like the cinema hall. And I have two columns, 1 and 2, and 3 rows, and I call them 5, 7, 8. And to find the Cartesian product x crossing y, okay, I will, yes, find the intersection points of each rows and columns. So I will have 6 chairs, 1 and 5, 1 and 7, 1 and 8, 2, 5, 2, 7, and 2, 8. And this graph, we called it Cartesian graph. This is x crossing y, and I will determine the 6 points from the graph, as we said. The second method is called arrow diagram. And arrow diagram, so I think we will use arrows to represent it. So I will have my two sets, x and y, and represent each one of them in a rectangle, like you see now. We represent x in this rectangle, and it has two items, 1 and 2. And we'll represent y in another rectangle, which have 5, 7, and 8. Then I will begin with every item in x, and distributed in every item in Y using arrows. So I will begin with 1, 5, 1, 7, 1, 8. So 1 distributed in every item in Y. Then I will transfer to 2. So I will have 2, 5, 2, 7, 2, 8. And because of all these arrows, I called it the arrow diagram. Even if I represent the Cartesian product graphically by the Cartesian diagram or the arrow diagram, both is true, both is clear. If the question determined which diagram I will use, so I will use it. Okay, so now I can find the Cartesian product algebraically without drawing by a big set, have some ordered pairs. These ordered pairs, every first projection of them belong to the first set, and every second projection of them belong to the second set. And when I want to represent the Cartesian product graphically, I have two ways. The Cartesian diagram, which is like the cinema hall, and I will represent the first set horizontally and the second set vertically. The second way to represent the Cartesian product graphically is by the arrow diagram, and I will represent every set in a rectangle and then distribute every item in the first set on every item in the second set and use arrows to determine the direction. When I see the arrow diagram and I see 1 go to 5, 7 and 8, so it means X crossing Y. X is the first set, Y is the second set. So this arrow diagram represents X crossing Y. If the arrows are in the other direction, so 5 will be 5, 1, 5, 2, 7, 1, 7, 2, 8, 1, 8, 2. So the arrows will be look in the other direction. Okay, so it will be the Cartesian product of Y crossing X, not X crossing Y. Now we had learned the Cartesian product of two finite sets. What about two infinite sets? And infinite sets algebraically means that sets we cannot count their items. Like what? Like natural numbers or integers or rational number or real numbers. Okay, like n. When I said I want to find the Cartesian product of n crossing n, so I will represent n in the horizontal line and another n in the vertical line, and crossing each item in the horizontal line with each item in the vertical line, and we'll find the Cartesian product, which will be infinite too, and we will see that in the second or in the next slide. So n crossing n will be set have an ordered pair x and y, where x is the first projection belong to natural number and y as a second projection belong to natural number 2. And I will have z crossing z, which is integers, q crossing q, the same idea, and finally r crossing r, real numbers crossing real numbers will have ordered pair x, y, and x belong to real numbers and y also belong to real numbers. Now I want to represent each of these blue boxes graphically. First, representing the Cartesian product of n crossing n, and I call them n power 2. So I will have two axes, x and y, and have natural numbers in the horizontal and in the vertical axis, and then find the crossing points of every these two axes, and I can represent many or infinite semi-majors here, like this point A, which I can call it 3, 4. B will be 2, 9. C, 6, 5. Okay? And what if I want to represent the Cartesian product of z squared? Z crossing z. So I will use the number line of z, which is extended in both directions because I have negative and positive. So I will have x and x bar and have y and y bar right, and something like that. Okay? And will determine any point in this plan. Any point in this plan. And any point in this plan also can be determined easily. Like A here. I will set the x-axis projection first, which is -2, then the y, which is -2. So A here, -2, -2. B, -3, 2. C, 2, 1. Is that easy? I hope so. Now I want to find the Cartesian product of R crossing R or R square, and pay attention for a little more time. Like integers, I will have two axes extended in the two directions, x and x bar and y bar, and I will have a numbering system like that. But in integers, okay, I was talking about 1, 2, 3, 4, and numbers, whole numbers. In R, I have all the numbers between 1 and 2, not 1 and 2 only, no, all the numbers between 1 and 2, all the numbers between -3 and -4. And we know that we have infinite number of numbers between every two integers. Okay? So I cannot determine the crossing point by extend lines as I did before, but I will extend plan area, because I have many infinite rows between 1 and 2. All the numbers between 1 and 2, I can determine it here. So I will have something like this point A, which is -1, -2, and B, -4 and 1, C, 3 and -2. Okay? What about if I have a point between 1 and 2? How can I determine it? I will say that 1.5 and 3.4. Yes, it's belong to R square. Okay? Now, I have this Cartesian product, R square. Okay? I will divide this Cartesian product, this is very important, to first quarter, to 4 quarters. First quarter, second quarter, third quarter, and fourth quarter. I will begin with the first quarter and then make a circle anti-clockwise. So I will go in this direction. 1, 2nd, 3rd, 4th. And it's so important noted that any point in the first quarter, it's two coordinates, it's two x and y in its order pair are positive. So in the first quarter, x more than 0 and y more than 0. And in the second quarter, any point will have negative x and positive y. So x will be less than 0 and y will be more than 0. Third quarter, both x and y are negative. So x and y less than 0. In the fourth quarter, x is positive and y is negative. So x is more than 0 and y is less than 0. It's so important. Now, this example, he said that x equals to closed interval 0 and 3. So I'm talking about real numbers. Integers, I said 0, 1, 2, 3, 4 because I'm talking about whole numbers. Here in real numbers, I cannot talk about some numbers. I talk about intervals. Some interval because I have all the number between 0 and 3, including 0 and 3, because it's closed interval. And have y equals the closed interval 1 and 3. And I want to represent x crossing y. I want to represent x crossing y. So I will first, draw my horizontal and vertical line in R. It's extended in both directions, like that. Okay. And now I want to represent x. Then represent y. Then find the crossing area between x and y. So how can I represent x? I will go to the x-axis and find the period 0 to 3 and extend it in both directions, like that. This is the area of x, which is 0 and 3, and extended in both directions. And then we'll represent y, or will represent the second interval on the vertical axis, which is 1, 2, 3. So I will go to y-axis and represent this interval on it, like that, 1 to 3, and will extend it in both directions. The common area here, or the intersection area between the interval of x and the interval of y is called the Cartesian product of x crossing y. I wish you will find these examples are useful and easy. The Cartesian product definition and representation is so important to understand well what its function and relation means, and this is our uh, incoming lesson. Uh, I want to study these examples well and do your homeworks completely and understand the meaning of the Cartesian product. Thank you very much. Goodbye.